In this video, we're going to add a steering component and we're going to talk about anti-squat and anti-lift. Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to carry on with our car suspension example, and this time I've added a few more solid bodies, a couple components, simply because it's going to be easier for us to visualize what we're doing if we can see some stuff move on the screen. At this point, it's been fairly conceptual. Obviously, there's a wheel and tire, but we haven't really created any geometry. Now, even though I have created a couple of extra components and I have added some solid geometry, again, it is not required for us to do this. But let's just talk about what I've added, what I've removed since our last example, and what we're going to talk about in this video. So I've added a steering wheel as well as a steering shaft. The steering shaft component is empty. There are no bodies, components, or sketches. I simply used it so that I could add a revolute joint to the steering wheel based on its current location. I've also added a component called rack and pin, and inside of there I've created a housing and a shaft. These currently do not have any relationships with each other. You'll see that the housing itself is grounded as well as the rack and pin. Now, in the case of subcomponents in an assembly, it's important that we understand that if we simply ground the top level, the stuff inside still has its own coordinate system and it's free to move about. So we need to be mindful of what we're actually pinning or grounding and what we leave free to move. So in this example, I've also removed the component that we had for steering that let us see bump steer. The wheel still moves up and down. It just doesn't turn. It just doesn't steer. So we're going to use these components. We're going to create a motion link between them so that way we can actually control a rack and pin. And then we're going to talk about accounting for bump steer. And ultimately, I want to talk about changing the pivot axis for each of the upper and lower control arms. Now that's going to help us if we're trying to plan some anti-squat or anti-dive, depending on if you're dealing with front or rear. There are a lot of things that we're not going to get into. We're not going to be talking about the fundamentals of geometry setup. We just want to look at the ways in which we can account for it in this sort of 3D ghost assembly. So now that we understand what we're doing, let's go ahead and go to Assemble. Oh, also the assembly you see here, you can download from the description in the video. So go ahead and open that up and play around with it if you want. We're going to go ahead and begin by adding a joint, and we're going to use as-built joints. So the first thing that we need to take a look at is we need to see a couple of the different joint types that we could use for rack and pin. We've got a slider, we've got cylindrical, and we've got pin and slot. And it's important that we understand the differences between these three. The slider option allows us to simply move along an axis. The cylindrical allows us to move along that axis and rotate about the same axis. The pin and slot allows us to move along an axis, in this case a slot, and rotate about a different axis. So in the case of a rack and pin, we're going to be using the slider because it's going to be a gear system and it's only going to be moving left and right. It's not going to rotate. So the slider is going to be between the shaft and the housing, and then we need to pick another location. And in this case, what I want to do is I'm going to hover over the shaft. I'm going to hold down Control or Command if you're on a Mac. Then I'm going to move the end point or the location to the end or the middle of this component. The reason that I want to do this is because that helps when we get into taking care of limits, if we want to modify the limit of that joint. It's also important to note that we have a joints folder at the very top level, but because the joint between housing and shaft were all internal to this rack and pin component, it has its own joints folder now. So if we want to find that, we need to go in there and take a look at it. We're not going to be adding the limits now, but let's take a quick look by just going to Edit Joint Limits. And note that the min and the max values now are going to go from 0 to a positive value. If we had set the pivot point or the snap point somewhere else, then we would be going negative and positive, or we might be going completely negative, and it just becomes a little bit more complicated to deal with. Again, not really required, but that's the reason why I stick that point at the midpoint or the end of the object. Now let's create a system where we can turn the steering wheel and we can have the rack and pinion move. To do that, we're going to use what's called a motion link. We need to simply select the joints, and this is easy because they're all still visible. We select the revolute for the steering wheel. So we're going to link this joint and we're going to link the slider joint. Now, here's where it gets a little bit tricky for us is we want to make sure that we understand the amount that we're moving and the direction that we're moving. And with the animate, it's really hard to see because it's going extremely fast. So let's simply hit OK, and then let's take a look at what happens. So as I move this wheel, you can see that it's taking a lot of revolutions for me to get any sort of motion out of that link. So what I want to do is I want to go back into that joint, the motion link 10, edit feature, and now for every full turn of the wheel, we need to decide how far we want that component, our steering, to move. Now, if you're working on an actual car, you have actual data. You can know that you have a certain number of turns on the steering wheel will equate to how much, lock to lock. But the extra piece of that information is you need to know how much your rack is actually moving. For this example, I know that I want this to move probably about 4 inches. So for one full revolution of the steering wheel, I want it to move 4 inches. We could also say this is 180. So we get 4 inches for half a revolution of the steering wheel. Now you can see that it moves quite a bit more. Another tricky thing is the way that this wheel is set up, we're actually looking at it from the front. So this would be the front left wheel, driver's side if you're in the US. And what we're actually doing is we're steering it from the wrong direction. So we need to think about this. If we're turning the wheel to the right, this is going to be turning a point that's behind the steering axis, which means that it's going to be pulling it and the wheel will be turning to the left. So we just need to think about that conceptually. And again, the way that I have this set up, we're looking at it from the front and we're turning the wheel backwards. So if you need to reverse that, you just edit, you click the reverse option. So now when I turn to the right, it moves out to the right. When I turn to the left, it moves to the left. Now that we have our steering component set up, again, the bodies and components here were just really created so that we had a better visual reference. Now that we have those set up, we can go in and we can create a new component for the steering link. Remember, there is something that goes between our rack and pinion and the actual car. And that usually is going to have a ball joint or some sort of universal joint on both sides. So we need another component to replicate that. So in order to do this, I'm going to go ahead and create a new component, making sure that I am at the very top level. We're going to turn off the activate option, and I'm going to call this one steering link. Now, if you remember, we actually created one called steering link before, but I deleted it for this example. Okay, so now we have this component. It has its own coordinate system. And if you'll remember, the very first time we started this, I mentioned that the origin is going to be based on the default origin of the entire coordinate system. And if you want to move that, now is a good time to move it. So before we do anything, I'm actually going to move that coordinate system. And the main reason that you might want to do this is if you're using this conceptual model to then eventually design all of your components, then you want to make sure that those coordinate systems are in a reasonable place to start your design. So if you're using solid bodies to rough in the geometry and eventually translate that to something else, then we want to make sure that we do move it. So we can use move, make sure that we're moving a component, and I'm going to go point to point. I'm going to actually move it directly to the center of this as my snap point, but note that this is my target point. So the origin is actually going to be the default origin of the coordinate system we're moving, and then the target point is the center here. We're going to capture its position, which is required because we're moving a component. And now the origin of our steering link is placed directly at the end of our steering component before we've ever created any sketches or added any geometry. Again, the main reason you would do this is if you are using this assembly downstream and you want to actually create components for it, it's a good idea to make sure that your coordinate systems are where you expect them to be for your design. For me, it doesn't really matter because I'm not going to take this into 3D, or more so than what we have here, but it is a good idea. Another important thing to note is that that coordinate system is not going to move with our components. Everything in Fusion 360 is timeline based. When we think about everything being timeline based, the capture position for our coordinate system happened before we turn the steering. So if we were to capture this position, we would have another feature in the timeline. So again, it's important to remember that when we think about moving coordinate systems and designing our components, it is still history based. Now that we have our components in place, the next thing that we want to do is we want to create some joints between our steering link and anything else that it's going to attach to. So we're going to do as-built joints again, making use of the current coordinate system. And I'm going to place a ball joint between my steering link and this component here, which is the slider for my rack and pinion system. And I want to make sure that I place it directly at the center. We're going to assume that's the ball joint location. If you know that there are less degrees of freedom, you don't have to use a ball joint for this. But again, we're kind of going off the potential that we have a lot of degrees of freedom here. Well, in reality, you might only have a couple degrees of rotation in one direction and a couple in another. And if you know that information, then you can use the edit joint limits option to limit that. Once again, as-built joint between our invisible steering link and the point that we have on this hub. Now remember, I attached that sketch to the hub. It doesn't really matter because I can pick a point on any other object that I want, a sketch reference or solid body. But I do want to try to be mindful of where I'm placing these joints. So we're going to say, okay. Now, if we did this right, theoretically, when I turn the wheel here, you can see that the wheel now steers. Also, it should still move up and down. So now we've included steering as well as the vertical movement. And you'll notice that the steering itself is not moving the wheel up and down necessarily. Let's go ahead and revert the position. If we're just steering, you can see that the wheel it's got a slight rise and dip to it when we turn, but it's not drastic. And these are all going to be factors based on the location of any of our joints, our coordinate systems, the components that we have. But now we've taken a look at adding steering. And again, the only reason I added a physical solid body steering wheel and components to represent the rack is purely for visualization, so we can see what's going on. But now that we have that in place, let's talk a little bit about the axis of rotation for the suspension. Now, in reality, there are a couple different ways that we can do this. And I'm going to go ahead and find my wheel assembly, and I want to hide all of the components with the exception of this hub mount. This is the one piece that I want to keep. So I want to hide everything else. And we can do that by selecting them all, right-clicking and hiding them using Show Hide or V on the keyboard. Or we could use Isolate to just isolate the hub. But I did also want to keep the steering, and I wanted to keep the location of my rack and pinion. Now, in reality, again, the location of this really should be further back and up higher. I just placed it wherever I placed it. We can modify the sketch. We can move the geometry around. The joints, the location of the joints rather, will move with those components. So if this body moves somewhere, then the joint will move with it. But just keep in mind that I am not setting up optimal suspension geometry. We're just really looking at the process. So when we created our chassis component for the wheel assembly, the chassis component does have some sketches that represent exactly where we want our upper and lower pivot points to be. And originally we had a point or a vertex for our steering axis. So we don't need the steering axis anymore because now we have our rack and pinion set up. But what we do want to talk about is what happens if this isn't just a pure revolute and the upper and lower pivot points are not actually parallel with each other? What happens if we're trying to develop some anti-lift or anti-squat into our suspension? Well, in that case, then we need to actually physically create the axis that we want to revolve about. This can be done a few different ways, and I'm just going to simply go in and edit this first sketch. And note that we put these points at a couple different locations, but they were done from the front plane. If we want to take this into an actual axis of rotation, assuming that it's going to be parallel with the center line of the vehicle. And what I mean by that is if we create a sketch in our chassis, let's go ahead and activate the chassis. If we create a sketch on our right plane, we're going to assume that the angle is only in this direction, only in the YZ plane as we're looking at it. And what that means is that we're not accounting for any caster, camber, or toe in all these different directions. We're only looking at a translation of this axis in one. That doesn't mean that's how it has to be. If you create an axis in 3 dimensions, it'll work just fine. But again, just for simplicity's sake, we are going to do this only looking at the axis in the YZ plane. So I'm going to use P on the keyboard to project those 2 points that we already created. And if anything's in the way, we can always hide like the rack and pin just to get rid of it, because I want to bring this point in, and I'm going to say OK. Next, what I'm going to do is create a line. I could also create another point and just simply use an axis, but I'm going to create a line here, and then I want to do the same thing on the bottom. Now, maybe the bottom is parallel with the ground, and we can say OK. Now, in general, just really quick, when we're talking about the projection of these axes, we're going to have some sort of projection. I'm going to go ahead and make this 8 degrees, but we're going to have some sort of projection of these out. So we could, again, do our same trick using collinear relationships, and we could take a collinear here. Obviously, if that is parallel with the ground, these are going to be really far out. And where they intersect, I'm going to add a coincident relationship. And then if we go back to our wheel assembly and we take a look at the actual tire, so I need to find the tire component in here, right here. So if we take a look at the tire itself, where it contacts the ground, that would be the point where we would want to look at the intersection. And then we would want to carry that line collinear. Again, these are going to be collinear. And we would want to carry that into the center line of the vehicle. So this would touch where the wheel or the tire touches the ground, and then we would sort of project these out. And this would help us better understand the location and the sort of moment that we're going to have on the center of gravity. And that's going to help us determine things like anti-squat, anti-lift, depending on if we're working or front or rear. But again, it's a bit outside of what we're talking about here. I just wanted to make sure we understood that these axes will project similar to how we did it in our 2-axis sketch. So now that we have these references here, let's go ahead and let's bring back everything else, even though we don't really need to. We can go to the very top, we can right click, and we can say show all components and show all bodies. And that'll bring everything back without us having to manually select everything, and then just activate the top level. So initially, what we did was we created these revolute joints, the upper arm and the lower arm joints, and they were based specifically at a point. We use that point as the center, and if we take a look at editing these joints, when we do that, because the joints were applied very early on, what ends up happening is they were applied well before we created that sketch. Now, that sketch, the reference that we used is actually doesn't rely on anything else in this design. It doesn't care that I added all this other stuff here. So we could take this sketch and we could simply drag it all the way back and put it in the right location. Or we could take these and we could suppress them. So the upper and lower arms, we're going to go ahead and suppress those. We're going to find those components. So I'm going to go ahead and take a look at the upper and lower arms. And then we can re-add the joints at the chassis. So again, these are going to be as built because it's in the right location. If it's not, make sure that you do revert its position. And notice that when we revert the position, that it's actually unsuppressing these upper and lowers. So let's go ahead and since we didn't move anything and we know we didn't, we'll capture it. Then we'll go to as built joint. It's still going to be revolute because it is going to be a single axis for both mounting points for the upper and both for the lower. If that wasn't the case, if you were using something like a Rose or a Heim joint and building your own, and they were actually off axis, you would want to account for those individually. But we're going from the upper arm, and we're going to go to the chassis. Now the location, in this case, I'm actually going to select the axis instead of a point. The reason that it's important that we select the axis is because the coordinate system or the revolute is going to be normal to that axis. So we don't have to worry about a point. It's going to be very hard to tell, but when we go from the axis to the point, it's actually going to switch to the standard coordinate system. It's going to be rotating about the y. So we're going to select that there. We're going to say OK. We're going to repeat the process again between the chassis, but this time with the lower arm, and our location is going to be that axis. We're going to say OK, and theoretically this worked. So now if we move the wheel up and down, you can see how it moves. All right, so let's revert the position. Notice that there's sort of a fake tire in there, and that's because the very top level in this bodies folder, I have this body that I used to create the inside surface where I was cutting the tire treads out. So show all bodies brought that back. We'll just make sure that we hide it. So now we're in a situation where it's really difficult for us to control, right? So we've got this situation where we have these degrees of freedom that are great, but now it's become a little bit uncontrollable. And the way that we can control this is we can use a motion study, or we can find, again, individual joints like this upper and lower. I'm going to rename these upper 2, and I'm going to rename this one lower 2, just to kind of remember what they are. But now that we have these, what we want to do is we want to either drive them or we want to take a look at using a motion study. So let's take a look at upper 2 first. I'm going to right click. When I drive the joint, it lets me manually move that joint around. And notice that the steering wheel is still moving. So we still have the same problem when we're driving it. But let's take a look at what happens when we create a new motion study. So in the motion study, we need to select the joints that we want to move. In this case, the steering is one that we want to control, and then the revolute for the upper or the lower arm. It's not going to matter, it just depends on which one you want to drive. Now that we're controlling those, I'm going to minimize this and sort of pull it over here so it's easier to see. Now that we have both of those, we need to pick which one we want to move. So you can see we've got red, and the red represents the revolute, which is our steering. This is another reason why naming them is good. I didn't name that one. And then we've got lower. So again, I want to come in here, and this time at 20, I'm going to say minus 10 degrees and hit enter. Notice that it's pushing it the wrong direction now. We reapplied that joint, but we want to make sure that our steering, the steering itself, isn't moving. So I'm going to play around with these numbers a little bit. Maybe we'll go to 2. And that's at step 20. And then we want to make sure that the revolute is the one that's not changing. And you can see here that the revolute is actually adjusting its angle, and we want to make sure that it doesn't adjust anything at all. So this value we're going to turn off, and let's just play through this motion and see what happens. So select the blue one, we'll make it go up 10 degrees. We're going to go a little bit further, and we're going to come back down to 0. So we're going to reduce the speed, loop it, and let's just play it. And you can see that the steering wheel is turning as we go. So I'm going to select my steering, and I'm going to add that in, and I'm going to set this at 0, and I'm going to drag that point. I want to make sure that it's 0 here as well. And now I've got 2 points relatively close together that are 0. I'm going to stick another one there to make sure that one's 0. And this first point, it automatically came in at -4. I'm going to leave it, and we're just going to play through. And now it locks the steering wheel in place. So you can see that now we can see exactly what the effect of having the steering in this position is. We're getting an extreme amount of bump steer because the steering is in a bad location. And again, what we can do is we can find that component, in this case the rack and pin, and I'm going to unground it. The housing, I'm going to unground that as well. I'm going to take a look at this from the top. I'm going to select Move Components, and I'm going to move the entire rack and pinion unit, and I want to just free move it. I'm going to pull this backwards, and notice that as I pull it, it's actually moving the wheel because the joints are active. So I want to put it in a location that makes sense for reducing the amount of bump steer we have. So this is our steering axis. We want to push this up, and we want to rotate this around. And notice that it's causing a lot of steering that's happening here, and that's simply because of the coordinate system and the relationship that we have between the joint. Remember, there's not a physical body here. We just have a sort of a fake component. So what we're going to do is we're going to say OK to this new location. We're going to capture its position, and then we're going to redo the joint. In case this ball joint, I'm going to suppress it. I'm going to rotate the wheel back straight. And we could do this by manually driving any of these joints that we want, but I'm going to put it back to straight. I'm going to capture its position, and then I'm going to create that as-built joint again. So again, it's going to go between the shaft, and it's going to go between the steering link. So I need to find my steering shaft or steering link, and then it's going to be a ball joint, and its location is going to be right here at the center. So we'll say OK. We'll make sure that inside of our rack and pin that we ground our housing and that we ground the rack and pin. And now if we take a look at this, we should still have steering, and we should be able to move up and down. And now we can go back to our motion study. We can edit, and notice that this has changed. Let's play through, and let's adjust the height of this. So this was 2 degrees at this point. Let's go ahead and make sure that it's a little bit higher. Let's set it to 15 and see what happens. And let's just play through. So as you can see, it's not a perfect solution. It does take a little bit of work, but we haven't designed any components yet. And now as we play through this animation, we can see that we have a lot less bump steer. There is some interesting things happening because as it goes up, we are still turning the steering wheel just a little bit. So we would need to make some adjustments here. Let's go ahead and pause this and see if we can add a point here. I'm going to set that to 0. And let's go ahead and let's set the step value to 20. This can be kind of tough to do sometimes. I'm going to hit minus to get rid of that one. This point right here, there's not actually a dot. So one thing that we can do is we can suppress this or delete it completely and then bring it back as needed. So I need to find Rev 9. I want to add that joint. So we're going to make sure that we add Rev 9. Now that it's completely at 0, it looks like it's moving just a little bit still, but you can see here that now we're getting a little bit of toe out, which means that we need to make some additional adjustments because we certainly don't want it to go toe out when we're compressing the suspension, because that's going to cause an instability. Now, if it's the rear, then that's okay. If it's the front, then we kind of want it to toe in a little bit. But this is just, another way that we can apply some of these techniques. The more that you add, kinematically speaking, the more complicated this process is going to become. It's very easy for us to come in and add things like steering, but then it complicates moving the suspension up and down. And this is true in reality. If we built this out with all solids and we used all the components and added these joints, we would have the same issue because we're not locking any of these out. We can go in and we can take a look at some of these and we can lock them. For example, we can lock steering and then we can move this up and down and see the effect of bump steer. And then we can go back to that and we can right click and we can unlock it. That is one way in which we can use this to our advantage and still have all of these joints kinematically speaking. But again, the more we add, the more complicated this gets. So if you're trying to design a suspension system or play around with it, I would start with the absolute basics. I would avoid putting steering in, but I would include things like a sort of a dummy steering link, so that way you can account for bump steer. But make sure that you do plan this out ahead of time, because the more we try to add and sort of manipulate things, the more complicated the process becomes. So at this point, I'm going to go ahead and put this version in the description of the video as well as the one we started. So that way you can play around with this and you can kind of see how you can manipulate it and break it. Again, just some of the best practices. Make sure that if you plan on using this downstream to design something, that you move the coordinate systems of those empty components to a location that makes sense. It'll save you a lot of headache downstream having to delete some of these joints and then add them back in. And one of the good things is if you use this assembly to design your solid components, you really don't have to go in and do much work in order to get them to animate properly. And what I mean by that is, let's go ahead and I'm going to activate the lower arm. I'm just going to create a very simple lower arm. Now remember, we are going from that point there. So if I hide the steering wheel and I take a look at this point, I'm going to say P on the keyboard to project that and that. I'm going to just add some very quick circles. This is going to be a basic representation, so please don't assume that this is a final deal here. But all I'm going to do is just create a very simple link from the side. I'm going to extrude this. And again, I'm just looking at, a very general, simple single link. I didn't even put holes through the center of it. But now if we look at this and we move around, you can see that it moves up and down with the wheel. So we didn't have to do anything additional because the component that we created to hold that, the lower arm, already has all the relationships that it needs. However, the coordinate system was not really in a great place. It was in the center of the wheel rather than being in the center of the component. So again, just keep that in mind. If you're planning on using this downstream, think long and hard about where you want those coordinate systems to be and move them before you get started. But at this point, if you have any questions, please let me know. I am not planning on taking this set of videos any further. From here, the topic gets extremely complicated and it's more of an engineering topic than it is a setup. But if you try to do this on your own and you run into any problems, please let me know. You can comment in the video or you can send me an email, support@caducator.com, and I'm happy to try to help out and answer questions. So, as always, thanks for watching. Appreciate it, and I'll see you in the next one.